Good morning, all of you. Today, let's see the properties of rational number. Okay, today we will start the properties of rational number. And the first property that we are going to study is what? Closure property. Okay, so before discussing the closure property for rational numbers, we will be discussing closure property for whole numbers. Okay, and then we will be discussing it in the case of integers, and then at last we will be discussing it for rational numbers. So the first one is closure property for whole numbers. Let's see that. So closure property means what actually? That means let's see it in the case of addition. Okay, let's see whether the whole numbers are closed under addition or not. Okay, so for the case of addition, what you have to do, you have to take any two rational numbers. Any two whole numbers. Now we are seeing the closure property for whole numbers. So you have to take any two whole numbers. Suppose I am taking the whole number 1 and I am adding it with any other whole number. Suppose I am taking 2. Okay, then what will be the answer? 1 plus 2 is 3. That means I have taken a whole number and added it with another whole number, and the answer is also another whole number. Okay, and suppose I am taking any other whole number, say I am taking 0 and adding it with any other whole number, say 7, and what I am getting, what is 0 plus 7? It's again 7. So here I am adding any two whole number and the answer is also a whole number. That means you can say what? Whole numbers are closed under addition. Okay, that means if you are adding any two whole numbers and the result is also a whole number, then you can say that whole numbers are closed under addition. Okay, now let's see what is the case for subtraction. Suppose I am taking 5, okay, and I am subtracting 2 from 5. Then what is 5 minus 2? Answer is 3. So here 5 and 2 are whole numbers. So I am subtracting 2 whole number and the answer is also a whole number. So this is true, but let's take any other example. For example, I am taking 5 and subtracting 7 from 5. Okay, then what will be the answer? You know that 5 minus 7 is what? Minus 2. Okay, so here 5 and 7 are both whole numbers, but the answer minus 2 is not a whole number. It's an integer. That means when you are taking two whole numbers and subtracting them and the result is not a whole number, that means what? Whole numbers are not closed under subtraction. Okay. So whole numbers are closed under addition but not under subtraction. Okay. Now what about multiplication? Let's see that. Suppose I am taking 3. Okay. And I am multiplying 3 with any other whole number, say 2. What is 3 into 2? You know that it's 6. So I am multiplying two whole numbers and the answer is also again another whole number. Okay, and now suppose I am taking 0 and I am multiplying it with 3. Then what is the answer? Answer is 0. So here also I am taking two whole numbers and multiplying it and the answer is again another whole number. That means what? Whole numbers are closed under multiplication. Okay. Now what about division? Let's see what is the case for division. Suppose I am taking 5 and dividing 5 by 1. Then what will be the answer? You know that 5 divided by 1 is what? 5. So you have taken any two whole numbers and the answer is again a whole number whenever you are dividing. But let's see any other example. For example, 5 divided by 2. Now what is the case? What is 5 divided by 2? You will get the answer in this way, 5 by 2. Here 5 by 2 is not a whole number. It's a rational number, is it? So you are taking two whole numbers and dividing them and the answer is not a whole number means what? Means whole numbers are not closed under division. Okay, so the only thing that you have to see is that you have to take any two whole numbers and you have to add them at first and see the result. Then you have to subtract them, see the result, multiply them, see the result, divide them, see the result, and you will see that in the case of addition and multiplication, result will be a whole number itself. But in the case of subtraction and division, result will not be a whole number. That means, in conclusion, you can say that whole numbers are closed under addition and multiplication, but whole numbers are not closed under division and subtraction. Okay, this is the result you are getting from this. Okay, these are the conclusions that you are getting. Okay, and you will see that whenever you are doing the same thing with natural numbers means what? You have to just avoid the number 0, then you will get the natural numbers. And when you are doing the same operations, that is addition, multiplication, subtraction and division, with what? Natural numbers, you will again get the same result that we are getting in the case of what? Whole numbers. So you can check the case of natural numbers by doing the same steps. Okay, and the result will be the same. Okay, so this is what the conclusions that we are getting from whole numbers. So this is the closure property for whole numbers. We will see the closure property for integers also. Okay, let's see that. So here, let's take any two integers. Suppose I am taking 5 and 2. Okay, you know that 5 and 2 both are integers. And I am adding this 5 plus 2. Then what will be the answer? Answer will be 7, which is again an integer. Let's take any other example. Suppose I am taking minus 1 and I am adding it with what? Minus 3. Now what will be the answer? Minus 1 plus minus 3. You know that the answer will be minus 4. Okay, so again answer is also an integer. Now let's take any other example. Suppose I am taking minus 5 and adding it with 0. Then what will be the answer? It will be minus 5. That means if you are taking any two integers and adding them, answer is again an integer. That means you can say that integers are closed under addition. Integers are closed under addition. Okay, that is, you are taking any two integers and adding them, and the answer is also an integer. From that you can say that integers are closed under addition. Okay, now let's take the case of subtraction. Okay, suppose I am taking the same number 5 and subtracting 2 from it. Then the answer is 3. So here you are taking two integers and subtracting them, and the answer is also an integer. Now let's take any other example. Suppose I am taking minus 1 and subtracting minus 3 from minus 1. Then what will be the answer? You know that answer will be minus 1 plus 3. That means plus 2 will be the answer. So here also you can see that you are taking any two integers and subtracting them, and the answer is also an integer. That means here also integers are closed under subtraction. Now let's take any other example. Minus 5. Okay, and I am subtracting 8 from minus 5. Then what will be the answer? You know that answer will be minus 5 plus minus 8. What is the answer? It's minus 13. So here also you are taking any two integers and subtracting them, and the answer is also an integer. Okay, so here you can say that integers are closed under subtraction also. Okay, integers are closed under subtraction also. Now let's see the case for multiplication. I am taking number 5 and multiplying it with 2. Then what will be the answer? Answer will be 10. Okay. Now what is 5 into 2? 10. So here I am taking two integers and answer is also an integer. Now minus 5 into minus 3. What will be the answer? You know that the answer will be 15. So here also I am taking two integers and multiplying them. Answer is also an integer. So here also you can see that integers are closed under multiplication. Now what about 0? If I am multiplying 0 with minus 3, what is the answer? 0 itself. So here also I am taking any two integers and multiplying. Answer is also an integer. Okay. That means you can say that integers are closed under multiplication also. Okay. Integers are closed under multiplication also. Okay. Now let's see the last one, that is division. So for division, let's take minus 5. Okay, minus 5 divided by minus 1. What will be the answer? Minus 5 divided by minus 1. You know that the answer is 5. Okay, so here you are taking two integers and dividing them, and the answer is again an integer. Now what is the case when you are dividing minus 5 divided by 2? Then the answer will be minus 5 by 2. Okay, so here you are taking two integers and dividing them, but the answer minus 5 by 2 is not an integer. That means what? Integers are not closed under division. Okay, that is the answer for this. Integers are not closed under division. Okay, so how can you conclude in the case of integers? What is the conclusion for integers? So this is the conclusion that we are getting, that is integers are closed under addition, subtraction and multiplication, and the integers are not closed under division. Okay, integers are not closed under division. That is, you can see here, in the case of closure property for whole numbers and integers, the only thing that you have to do is, in the case of whole numbers, you have to take any two whole numbers and add them, subtract them, multiply them and divide them. And if the answer is again a whole number, then you can say that whole numbers are closed under so and so. Okay, and in the case of integers, you have to take any two integers and you have to add them, subtract them, multiply them or divide them. And if the answer you are getting is again an integer, then you can say that integers are closed under addition, subtraction or anything as given in the question. Okay, so this is what the closure property says. I hope you understood the closure property for integers and whole numbers. Okay, only thing is that in whole numbers are closed under addition and multiplication, and they are not closed under division and subtraction. But in the case of integers, they are closed under addition, subtraction and multiplication, but they are not closed under division. Okay, so this is all about the closure property for integers and whole numbers. Okay, and we will discuss about the closure property for rational numbers in the next part. Okay, thank you.